In this video, we're going to look at the relationship between linear growth and exponential growth. So as we previously saw, a linear function is a function of the form f of x is equal to mx plus b, right? So our initial value in this case is b, and the slope is m. So the slope represents the amount that you add to the previous y value every time you increment x by 1. Now on the other hand, when you have exponential function, so f of x is equal to a times b to the x. So just a little warning. So these are different values of b. These are different b's. So that one up here and this one up here are different b's. But you have something of this form. So here a is the initial value and b is the growth factor. And we saw previously that the growth factor is what you multiply the output by every time you increment x by 1. So the difference between a linear function and an exponential function is that when you have a linear function, you're always adding the same constant amount, called the slope, every time x is increasing by 1. Whereas with an exponential function, you're multiplying the previous output by the same value, called the growth factor, every time you increment x by 1. So let's take a look at this. Suppose we have two functions that are very similar, except one is linear, so it has a initial value or vertical intercept of 1 and a slope of 2, and then a second function which we'll call g of x that's just equal to 1 times 2 to the power x. So again, it has initial value of 1 and a growth factor of 2. So let's see how these two functions compare. So let's make a table x, f of x, and g of x. So I'll make a nice table like this. And let's say x is equal to 0, 1, 2, 3, 4, 5, 6. That should do it. Okay, so let's do f of x first. Hope these columns are wide enough. So f of x starts at 1. If we plug in f of 0, right, f of 0, we just get 1, because 2 times 0 is 0, plus 1 is 1. F of 1, we plug that in, it's going to be 1 plus 2, that's 3. Now notice that the y value has incremented by 2. F of 2, well, that's going to be 1 plus 2 times 2. 1 plus 4 is 5. So we get 5. Notice again, the y value has incremented by 2. F of 3, we get 1 plus 2 times 3 is 1 plus 6. We get 7. Again, the y value has incremented by 2. And similarly, we get 9, 11, 13. So every time I move a step forward in x, the y value is increasing by 2, right? I'm just adding the number 2 to the previous y value. Now let's look at the case of exponential growth. So we still started with 1, right? G of 0 was just 1 times 2 to the 0. 2 to the 0 is just equal to 1. G of 1 is just going to be 2 to the power 1, which is 2. So far it looks like the linear function is winning. So let's see what happens next. G of 2 is going to equal 2 squared, which is 4. So we have 4 like that. So it looks like first we added 1 to the output, then we added 2 to the output. So let's see what happens next. G of 3, we get 2 cubed. 2 times 2 times 2 is 8. So we're multiplying the previous output by 2, and so we go from 4 to 8. Similarly, G of 4 is 2 to the 4th, which is 16, and then 32, that's 2 to the 5th, and 64, which is 2 to the 6th. So we have 1, 2, 4, 8, 16, 32, 64, and so forth. Now what's happening here is the previous output is always being multiplied by a factor of 2. If we multiply 1 by 2, we get 2. If we multiply 2 by 2, we get 4. If we multiply 4 by 2, we get 8, and so forth. So this is the basic distinction between linear functions and exponential functions.